Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P16E5, is associated with a LIN communication error, specifically between the Powertrain Control Module, PCM, and the DC-DC converter in the Honda Civic models from 2022 and onwards. The peak load current, PLC, runs the electrical components in your vehicle, from the infotainment system to critical engine management. The PCM plays a crucial role by processing various signals and managing the entire powertrain functionality. It relies on a local interconnect network, LIN, to communicate effectively with the DC-DC converter, which is responsible for regulating voltage and powering electronic components. A failure in this communication indicates to the PCM that something is wrong, prompting it to store the DTC P16E5. This interruption can lead to various operational problems, necessitating thorough diagnostics to resolve the issue. The DTC P16E5 error implicates several key components in the vehicle's electrical system. The Powertrain Control Module, PCM, is responsible for controlling engine functions and receiving vital information from other components. The DC-DC converter is crucial for converting the voltage from the vehicle's battery to a usable form for various electronic units. In some cases, the LIN, Local Interconnect Network, also encompasses the 12-volt battery sensor, which detects the battery levels and communicates this information to the PCM. In a Honda Civic, these components are usually located within the engine bay, with the PCM often found near the battery and fuse box area. Properly understanding each part's function and location is central to effectively troubleshooting and resolving the communication error. Several potential causes could lead to the DTC P16E5. Firstly, a LIN communication failure could arise due to a malfunction in the wiring or the components interconnected via the LIN. This system is vital for seamless communication among various components, so any break in this signal path can trigger the DTC. Open circuit issues where wires are disconnected or have poor integrity can also create communication failures, leading the PCM to register an error. In contrast, short circuit conditions might occur if a wire contacts the ground or another live circuit, confusing the signals sent to and from the PCM. Identifying these conditions through systematic testing is essential to addressing the underlying problem causing the DTC. The symptoms associated with the DTC P16E5 are indicative of broader electrical issues within the vehicle. Primarily, the PCM will likely show an inability to receive signals from the DC-DC converter, disrupting its normal operations. Such a failure can lead to multiple electrical components malfunctioning, as they may not receive the proper voltage levels for their operation. This might manifest as dashboard warning lights, erratic behavior from electrical accessories, or even startup problems related to battery performance. Additionally, users may notice intermittent electrical failures as components attempt to operate without proper communication with the PCM, leading to a frustrating driving experience. For the first troubleshooting step in resolving the DTC P16E5, begin by turning the vehicle to the on mode and allow it to sit in this state for about 10 seconds. This initial action enables the systems to self-check and establish connections between the PCM and other components, like the DC-DC converter. Next, it is crucial to check if DTC P16E2 is indicated concurrently. DTC P16E2 relates to similar communication issues, and if present, it could signify a more extensive problem in the system wiring or shared components. If DTC P16E2 is present, it may necessitate immediate investigation before continuing with P16E5's diagnostics, as resolving interconnected issues can streamline the troubleshooting process. In the second step of troubleshooting DTC P16E5, focus your attention on inspecting the external circuit components primarily connected to the LIN, Local Interconnect Network. Start with the IG1 ST-cut rally circuit, as any disruptions here may impact the entire communication line. You'll need to verify that this circuit has continuity and is functioning as expected. Following this, pay close attention to the LIN BAT sensor circuit, as this sensor is vital for measuring the battery performance and communicating this data to the PCM. Proper inspections will require checking for any frayed wiring, loose connections, or signs of corrosion that may disrupt the signal path, all of which could explain the communication error. Step 3 of the troubleshooting process necessitates a thorough inspection of the DC-DC converter itself. Since there is no direct way to test the converter, this step involves assessing the integrity of its connections and searching for visible defects. Start by examining the DC-DC converter connector for any looseness or corrosion that could impede proper function. It's also important to verify that there are no shorts or disconnects in its wiring harness. If the inspections return no abnormalities, proceed to check whether the DC-DC converter itself is operational under normal conditions. Should abnormalities arise, this component may need replacement to rectify the communication error flagged by DTC P16E5. The fourth step in troubleshooting DTC P16E5 requires inspecting the Powertrain Control Module, PCM. If all prior inspection items have indicated normal conditions, the PCM is likely at fault. This step involves performing a detailed function check of the PCM to ensure it is processing signals correctly. A malfunctioning PCM may struggle to communicate with the DC-DC converter, ultimately causing the DTC to trigger. Various diagnostic tools can assist in assessing the PCM's performance, focusing on reading sensor inputs, outputs, and overall functionality. If diagnostics confirm a fault within the PCM, then it will need to be repaired or replaced to clear the error. After completing all the necessary inspections and rectifications associated with DTC P16E5, it's vital to conduct a final repair verification. Start by clearing the stored DTC from the PCM using a suitable diagnostic tool. Post-clearance, confirm the status of the system to ensure that all components are communicating effectively. A subsequent test drive will help monitor if the vehicle operates without any persistent issues. Special attention should be given to any unusual behavior in the electrical systems during this test drive. Ensure that no new DTCs are stored in the PCM, signaling that the repairs have successfully resolved the issue linked to DTC P16E5. Preventive maintenance plays a crucial role in avoiding future occurrences of DTC P16E5 and associated issues. Regular inspections of your vehicle's electrical circuits will help catch any potential problems before they develop into larger failures. Make sure to maintain clean and tight connections throughout the drive system, as dust, debris, and corrosion can directly impair communication over the LIN. It's advisable to replace any damaged wires or components to ensure they do not lead to disruptions in signal transfer. By following these maintenance tips, you will enhance the reliability and longevity of your Honda Civic's electrical system, minimizing the chances of DTCs related to communication errors. In conclusion, comprehending the roles of the PCM, DC-DC converter, and LIN communication system is critical when addressing DTC P16E5 issues. A systematic approach to inspection and troubleshooting will often lead to efficient resolutions, identifying whether the root problem lies within wiring, individual components, or the PCM itself. Documenting the conditions and errors observed during diagnostics will help communicate issues more effectively in future inspections. Prevention becomes key as well. Through routine checkups and timely repairs, you can mitigate the risk of encountering similar DTCs in the future. By ensuring that all components are functioning optimally, you can maintain your Honda Civic's performance and reliability. Please like and subscribe to the channel. See you next time.